Hello, welcome to the topic 7 review. Here we go. I'm going to do the odds with you, and then I'll probably do the evens in class before the test. All right, so here we go. You have to do this worksheet before the test. We come to a right triangle, a friendly right triangle, and as always, you ask yourself, can I use Pythagorean theorem to solve for x? And the question is, yes, you could. Like that. You can see that up, a squared plus b squared equals c squared. And then work that out. Subtract that 36. Take the square over as a square root. And you get 8. Or you could have done all that, or you could have noticed this is 3 times 2. This is 5 times 2. This must be 4 times 2. It's a 3, 4, 5. 8 was the answer. All right, down to number 3, same idea. This is, we got a right triangle. We ask ourselves, can I do the Pythagorean theorem? Sure can. There's no shortcuts. We just have to hash this one out. So 4 squared plus 6 squared equals x squared. So that's 16 plus 36, which is 52. Do the square root. We have now solved for x. Read the directions carefully. It says reduced radical form. So that means we need to take 52 and reduce it. Now 52 divides by 4. 52 is 4 times 13, which then can be written like that, which then can be written like this. Okay. That's the answer. That's the answer I'm looking for. That's the answer on the test. Over here, when you square this, let's just do this real quick. When I do 2 root 3 squared, because that's going to be part of the problem eventually, don't forget you are squaring the 2. Okay? You're doing this, really. You're doing 2 squared times root 3 squared. That's what I don't want to call it distributing, but it's kind of like you're distributing. So this is really 4 times 3, which is 12. So we find that 2 root 3 squared will be equal to 12 eventually. Keep that in mind. Down here, what kind of triangle do they make? Do they even make a triangle? So the first thing you got to do is figure out if they make a triangle. To make a triangle, a plus b has to be bigger than c. That's step 1. Is 7 plus 8 bigger than 10? Yes. Always look at the largest side. Now, looking at the largest of these 3, you take it and you square it, and you compare it to the other 2 squared. It's an a squared, b squared, c squared thing, where c is your largest side. Now, in this case, we have 100 compared to 7 squared plus 8 squared. Let's see what that is. 7 squared plus 8 squared is 113. So that's 100 compared to 113. Now, the way I set it up, when I put the largest one first, this ends up being less. And to me, less always means acute. But it's always about this largest side. How does the largest side compare to the other 2? Now let's say I flip it. Let's just say I do the next one where I flip it. First of all, I got to decide, what is 2 root 10? I got to make sure. Okay, now let me add that to 9 just to make sure. Is it bigger than 14? Yes, it is. Okay, so this is bigger than 14. I'm good to go. And I'm going to set up, what if I set it up this way? What if I compare these with this one? Like that. Okay. What if I do that? Well, let's see here. It's my largest side. Now, again, not that we're distributing, but it's kind of distributing. You're squaring both of these, right? So this is really 4 times 10. So that's 40. That's 49 compared to 144. So 40 plus 49 is 89. Why did I say 49 there? That's 81. Come on. It's 7 squared. 81. 40 plus 81 is 121. So how does 121 compare with 144? Well, 144 is bigger. Now, up here in this problem, the arrow pointed to the left, and that meant acute. In this problem, the arrow is pointing to the left, and it means obtuse. What's the difference? Well, it's about the largest side. It's about the 14. 14, oh my gosh, 14 squared is 14 squared is 196. Come on, Smitty. 196. Either way, it's still the same. 196, 196, 196. 121 created 196. All right, it's about the largest side. The largest side is bigger than the other. So bigger means obtuse. This is an obtuse question. Okay. All right, just gonna work through these fairly quickly. That's just 10. That's 10 root 2. That's root 2. And this is root 2, which is root 4, which is just 2. 30, 60, 90. This is just times 2, and this is times root 3. I'm not teaching these at this point. This should be, I'm gonna do these problems and you're gonna say, oh, that's divided by 2, and that's 7 root 3. All right, down to 17. Let's find the sine, cosine, and tangent. Sine of x, cosine of x, tangent of x. All right, x is the angle in question. According to x, this would be our hypotenuse, this would be our opposite, and this would be our adjacent leg. So maybe it's good to label those first. So sine is opposite over hypotenuse, some old hippie. Reduce that to 3 over 5. Cosine is caught another hippie. Caught another hippie. AH, another hippie. 20 over 25. Which reduces to 4 over 5. And tangent. I'm not recording my thing so I don't get in trouble. Tangent. TOA. OA. 15 over 20. Reduces to 3 over 4. And that's it. That's all you're doing for those. Now, I would take SOHCAHTOA a step further and we use it to actually solve for an unknown side. Can't use Pythagorean theorem, can't use 30, 60, 90. This is a SOHCAHTOA problem. Typically when you have an angle, it's a SOHCAHTOA problem. So, I'm going to highlight 72. What do I have? What am I missing? I'm missing the hypotenuse. Which one does not use the hypotenuse? The tangent. The tangent of 72 will equal opposite over adjacent. That's x. This is the opposite. This is the adjacent to 72. All right. Now, technically what's happening, let me draw this all out for you. The x, we're going to multiply it by x. See what just happened? The x moved over to the left side of the equation. This is a number, by the way. So this is like x times that. Now I'm going to take this and move it over to this side. I'm going to take the 11 and now divide under the tangent of 72. See? I got rid of this. It's like I first started by crossing the x out, and then I crossed this out. So see what happens is that these two just switch places. That's how I like to solve those. So you plug that in your calculator. 11 divided by the tangent of 72. About 3.5. Does it say how to round? No. So 3.6 rounded to one decimal place. 3.6. X is about 3.6. Does my answer make sense? Sure. It's the short leg up here. It should be less than 11. I think feel pretty good about that. All right, next one. Here's my angle of reference. I've got the hypotenuse. I've got the adjacent leg. Which one uses hypotenuse and adjacent leg? That would be a cosine. The cosine of 34 is equal to 19 over x. Now, here's another way to solve this. Think of it as a proportion. In this case, you cross multiply and divide by the remaining number to solve for x. So I could do 19 times 1 divided by the cosine of 34. 22.9. Let's see if that makes sense. X is about 22.9. Does that make sense? Yeah. No, it doesn't make sense. That doesn't make sense, does it? This answer should be less than 19. What did I do wrong? The cosine of 34. What did I do wrong? You see it? Usually what happens when you have a contradiction, when that contradicts that, and you're pretty sure you did it right, there's a switch of the ratios. I should have done x over 19. Come on, Mr. Smith. It should have been x over 19. And in that case, I just multiply the 19 over to get rid of it. 19. It should have been 19 times the cosine of 34. 15.8. Okay, 15.8 would have been a better answer. That makes more sense because that is a little bit less than 19, 15.8. Now the question is, did I do that on purpose? Of course I did. All right, number 22. Find the missing stuff. All right, we got to find x and y. Look at 15. This would be our hypotenuse. This would be our opposite. This would be our adjacent. So I can set up the cosine of 15 and do a over h, adjacent over hypotenuse, 48 over x. And I can set up a tangent of 15 to do opposite over adjacent, y over 48. Okay. Let's see what we get. This one's easy, just multiply the 48 over, 48 tangent 15. 12.9. And this one, think of it as a proportion, cross multiply and divide. 48 divided by cosine of 15. You get 49.7. Okay, that's for x. This is for y. Everything working out here? Let's see. This is longest. 49.7 is the longest piece, and y is only 12.9. Can I check my answer real quick? Surely. All right, let's do a Pythagorean theorem. Let's do 12.9 squared with 48 squared. Okay, keep that number in mind. And now let's do x squared. And these should be pretty close. They're not going to be perfect because I did round. Those are pretty darn close. I think I did it right. I checked it using the Pythagorean theorem. Number 23. Find the angle of the indicated measure. So now we're taking SOHCAHTOA one step further, and now our unknown is the angle. So now we have to do the same thing. Look at the angle we're given. We have the opposite, we have the hypotenuse. This is a some old hippie question. Some old hippie. Okay. To get rid of the sign, you have to inverse sign. Like that. Plug that in your calculator. About 30. 7 degrees. We'll call it 37 degrees, sure. And I feel pretty comfortable with that. That looks like a 37-degree angle. Sure. That's a good one. All right, next one. I do not have the hypotenuse. So that's a TOA question. TOA, opposite adjacent. Here's my x. The tangent of x equals opposite over adjacent. So that means that x is the inverse tangent. To move it over to the other side, you have to do the inverse tangent. Inverse tangent. 24 over 45. 28 degrees. I feel pretty good about that. It does look like the more skinny angle. So 28 degrees looks good. All right, moving on. Final missing angles and sides. Once again, the right triangle. Can't use Pythagorean theorem. Can't use 30, 60, 90. I can find this. This is really easy. This is just 39. Now I'm going to call this A and I'm going to call this C. Why not? Actually, technically, I'd rather call this little b, right? Because it's across from big B. That's usually what we do. So in this case, if I highlight the 51, I can use the tangent of 51 to make 9 over B. And I can use the, let's see, what could I use to make 9 and C with 51? That's opposite and hypotenuse. I could do the sine of 51. Like that. All right, in both cases, this would be 9 divided by the tangent of 51. So that's 7.3 roughly. And this one is 9 divided by the sine of 51. And that's 11.5, 11.6 approximately. And I can check my work. Check my work with 9 squared plus, this was B, this was C. 9 squared plus 7.3 squared, and see if it's equal to 11.6 squared. Let's just check it out. Bam, and should be close. Not gonna be perfect, but they are close. I rounded, so I feel pretty good. Feel pretty good about my answers. All right, next, Brian's kite. Brian must be on the level ground somewhere. I always started with the level ground. Now look for the right triangle. Brian's kite is flying above a field at the end of his 65 meters of string. And we're looking at the height above Brian's head. There's Brian. He's flying a kite. He's got 65 meters of string out. And maybe he's looking straight ahead. And the angle of elevation as he looks up to the kite is 70 degrees. Here's my kite. There's my right triangle. This basically turns into just a right triangle problem. 70, 65, and my X goes there. How far above his head is the kite? All right. According to this angle, I've got an opposite and hypotenuse. I've got a some old hippie question. Okay, multiply the 65 over. Get our answer. Now it's going to be close to 65 because this is the bigger of the two angles. My diagram's not drawn very good to scale, but it gets the idea. About 61. So like I said, it'd be close to 65. About 61 meters. Don't forget your units. Last one we'll do is number 30. 14-foot ladder is used to scale a 13-foot wall. What angle elevation must the ladder make to be situated? Okay, so level ground typically is how I start. There's a building perhaps, and a apparently the wall, or maybe it's a wall. The wall is 14 feet. Nope, sorry. It's a 13-foot wall. My mistake. A 13-foot wall, and we're going to climb up the ladder. And it's a 14-foot ladder. 13-foot wall, 14-foot ladder. Angle of elevation. So if someone was right here and they were looking up, this would be your angle of elevation. That's where I'm gonna put my X right there. There's my right triangle, you can see it. Climbing up the ladder, angle of elevation. According to this angle, I've got an opposite, I've got a hypotenuse. I've got a some old hippie question. I got a some old hippie type of question. Get rid of the sign. And we'll give it an approximate negative inverse sign of 13 over 14. It's gonna be a pretty big angle, I think. Yeah, about 68 degrees. That's not so big. 68 degrees. Okay. All right, the other ones maybe we'll do in class before the test. We'll see. Enjoy.